Hi, my name is Lukas Grasse, and I'm a PhD student in Dr. Matthew Tata's lab down at the University of Lethbridge. And today I'm going to be talking about an end-to-end platform for human-robot audio interaction that Dr. Tata and I are developing through our company, Reverb Robotics. So I thought I'd start by giving a bit of a background on Reverb Robotics. So Reverb Robotics is a company that Dr. Tata and I launched in December 2018. And it's a company that's developing technology for auditory awareness and speech interaction for robotics and other autonomous systems. So Matt's the CEO and I'm the CTO. And we're developing an integrated hardware and software solution that's going to enable roboticists and other systems developers to get up and running very quickly with intuitive audio interactions. So I thought I'd talk first about how speech is a natural mode of interaction. So I have this quote from Donald Norman that says that it's the duty of machines and those who design them to understand people. It is not our duty to understand the arbitrary, meaningless dictates of machines. And I'd like to make the point that machine learning has enabled accurate speech recognition. And this speech recognition and auditory awareness is going to enable robots to intuitively understand people in a natural way, rather than having people learning maybe cumbersome interfaces or other ways of interacting with technology that isn't natural to them. That being said, these autonomous systems face unique challenges during speech interaction. So the systems might have limited space for hardware, such as microphones and computers to process the audio. There's also power constraints. They're usually operating in noisy environments, and there might be network issues. So making use of cloud servers might not always be an option. So the solution we're developing at Reverb Robotics consists of integrated hardware and software. So I thought I'd start off here by showing the hardware. So the first version of our hardware is based on the Raspberry Pi compute module. And it has Ethernet for simple network connectivity, and as well as a 3.5 millimeter audio input and output jack. So this is going to enable roboticists to get up and running with the speech recognition, and they don't have to worry about any of the software dependencies because everything comes preloaded on our board. And the dimensions of the board are pretty small at 7 centimeters by 4 centimeters. So it's going to easily fit inside different robot chassis. And it's also going to alleviate a lot of the network concerns as well as privacy concerns. And this is especially important for the healthcare industry. So all of our speech recognition software runs directly on this board. So we're not streaming audio from the microphones to the cloud or anywhere else because everything just happens right on board. And for the software side of things, we have a server client model. So the server that's running on the board can stream the raw audio out, as well as speech recognition results and natural language understanding. So that's basically a system that's taking the recognized speech and parsing the user intent, as well as different parts of the sentence that are important. And it'll also handle the text to speech. So it can take text and then convert it to speech, which is played on the audio output. And we're also providing a bunch of pre-built clients. So we have a ROS client. So if you're using robot operating system, you can easily integrate your existing system with our technology, and as well as a YARP client, which lots of our customers in Europe are using. And there will also be C++ and Python clients that communicate directly with the server using gRPC. So gRPC is the protocol we're using for all the communication between our different software modules. And that'll allow you to get up and running really quickly without having to worry about lots of dependencies. So I'd also just like to thank the following people and organizations for making this research possible. And yeah, I'm definitely looking forward to hearing from you if you're interested to learn more about our technology. Thanks.